Hello everyone, welcome to Deep Learning for Energy. So, at the end of last chapter, we hit a wall. Our regression lines and decision trees were honest and fast, but they only worked because we did the hard part for them. We handpicked the inputs such as temperature, the hour, yesterday's demand. We decided what mattered, and the model just turned the knobs. Now, look at this. Cloud drifting toward a solar farm, 60,000 readings per second. Try to handpick the features out of that. Obviously, you can't. We need a model that learns its own features straight from raw data. It begins with a single unit borrowed from biology called neuron. Take the inputs, multiply each by a weight, add them up, and add a bias. That is the same weighted sum from the last chapter we talked about. But now we added one new step, pass that sum through simple bend. The most common one is ReLU, rectangular unit, and it is comically simple. If the number is negative, output is 0, otherwise let it through unchanged. That bend is the entire secret. A straight line can only ever draw a single line. Straight line actually. Stack these bend units into layers, one feeding the next, and suddenly you can draw almost any shape. So the line became a curve, a coastline, likewise. Here's the idea worth slowing down for. As you can see in the screen, early layers learn simple things, later layers stack those into complex things. Feed in raw waveforms, then the first layer learns to notice edges like sharp changes. The next combines edges into shapes, a sag here, a surge here. The layer after learns that the shape is a fold. And nobody programmed any of it. The network discovered those features on its own. That is called representation learning. The model builds its own vocabulary for the problem. And the grid lives in time. So, as you can see, demand right now leans on demand a minute ago, or an hour ago, or this hour yesterday. So we want a network that can remember and walk through the sequence one step at a time, carrying a hidden state forward, as you can see in the equation itself. The running summary of everything seen so far. That is a recurrent network. Its cousin we are calling LSTM, long short memory, as you can mention. We can have a pattern from this morning all the way to night. So we are kind of like forget input and output gates. So these sequence models are the engine behind the modern forecasting. As you can see, the load, wind, solar, price, all are feed in the recent past. So they reach into the next few hours. But forecasting solar is not only about the past. The future hangs overhead in the clouds actually. Put a camera on the sky and ask, what will the sun be doing in 10 minutes? The tool is the convolutional neural network. It slides a small filter across the image and hunting for local patterns like edges, texture, the rim of a cloud, etc. Stack those filters and it learns to read cloud formations and how they move. The same machinery inspects the hardware itself. A drone with a thermal camera and CNN picks out hot failing cells, as you can see in the screen, across thousands of panels in minutes. So computer vision keep the power flowing in this scenario. One more, and it is quietly beautiful idea. You want to catch the moment something goes wrong, but faults are rare sometimes. It's hard to catch. That's the whole point of a fault. You have almost no example of wrong in specific scenario. So build a network shaped like hourglass, squeeze the input through a narrow middle, and force it to rebuild the original from that tiny summary alone. That train it only a normal operation, it becomes an expert at reconstructing normal and hopeless at anything strange. So when reconstruction goes badly wrong, that spike in error is your alarm actually. Now the honest part is deep learning is not free actually. These models are hungry. They want a lot of data and real compute to train. They are harder to interpret and on unfamiliar inputs, they can fail actually. When your features are clean and raw, the workhorses often win. That's the scenario. When the signal is raw or deeply patterned, that is when deep learning earns its place actually. We have taught machines to predict and to see, but what if they want to create or could create? For that, we need generative AI, and that is where we go next. Thank you for hearing me out.